Hello students, welcome back. Let's resume our discussion in section 2. Previously we studied mean, median, and quartiles. Here's a quick review. Mean is easy. Just add them all up and divide by the total number of items. Median may be a little bit new to a lot of students. It goes like this. First, sort the data. This data is already sorted out. Alright. And then knock off the smallest, largest, smallest, largest, smallest, largest, continue, and merge in. And that way you're going to get the middle number. In this case, we have 23 numbers, so there is one middle number, that's the median. Now, if you have even number of data like this, and knock off, and then in the end, you get two numbers here. Take the average of the two, and that is the median. So median in this case is 3.807, the average of these two. It goes right in the middle here. Median here in this case is 77, as you saw before. So median computation is really easy. You don't even need a handheld calculator for even... Okay, this may be a bit of a challenge, but in many cases, you don't even need a calculator for that kind of computation. Median is easy, but it is really strong. For example, what if I make this kind of stupid mistake? Somebody makes this typo and then run it. Does it affect median? No, it doesn't. But it affects the mean. That's because you're adding up this 8,800 plus all the other things and divide by total 23, so this one contributes. As for median, it's going to be knocked off immediately, so no problem there. Let's come back and check out again. Median, no change. Mean, we changed. In short, when you expect some outliers, then median is often more effective than mean. Median is simple, easy to calculate, but it's very effective, so it's really important. The next concept, quartiles. So here's a median, and then we take the low half of the data, and then we do the same thing. Knock off, and in the end we get the median of the low half. So 1/2 of 1/2, so 1/4 position, and that's called the first quartile, Q1. You can do the same thing to upper half. Exclude the median, and then upper half, and then knock off. In the end, you're going to get the middle number, and that is the third quartile. So 1/4 position, 1/2 position, and 1/3 position, or 25th position, 50% position, 75% position. We have these three, and then let's add two more. The minimum, the smallest, and the maximum, the largest. And these 5 colored numbers are called the 5-number summary. The 5-number summary. The minimum, Q1, first quartile. The median, Q3, the third quartile, and the maximum. 5-number summary. Let's go over there. So that's a 5-number summary. Lowest, Q1, median, Q3, the highest. Or minimum, Q1, median, Q3, maximum. Either way. Now let's go to Whisker Chart. Using 5-number summary, we can create a nice diagram that represents a rough distribution of data. Let's use sorted data, and then please pay attention to these colored numbers. These are 5-number summaries. Minimum, Q1, median, Q3, maximum. And run it. And this is so-called a Whisker chart. start from the minimum here, down here, and end at maximum there. So whiskers start from minimum and then end at maximum. And the box part corresponds to Q1 and then end at Q3. So start from Q1 and end at Q3. And then do you see this horizontal bar? That corresponds to the median. So the 5-number summary gives you the box whiskers chart and vice versa. You can find out 5-number summary from this box whisker chart. When you draw a box whisker chart, please use ruler. And with ruler and paper and pencil, you can draw an effective box whisker chart. Now, box whisker chart is given by 5-number summary. So in my opinion, that's the bare bone minimum of those data associated to the distribution of data. I mean, 5 is bare bone minimum. So if you draw a histogram and create a histogram with 2 rectangles, 3 rectangles, you're not going to get credit. 5 is the bare bone minimum. Even 5-number summary gives you 5 numbers. If you're doing histogram, it's got to be at least better than that. So 5 is the bare bone minimum number of rectangles in histogram. Okay, if you look at our textbook and go through my math lab, and there's another magic formula to determine the number of rectangles or the minimum number of rectangles necessary for a histogram, but that's a bit too complicated and it's not that important either. So let's go with a little bit, well, let me use the same term again, bare bone minimum. So bare bone minimum is 5. 5-number summary. So we went through something really important. Mean, easy but important. Median, quartiles, and then minimum maximum put together, we get 5-number summary. And that creates the box whiskers chart. Now, the next topic is percentile, and this is going to be really important later on in chapter 6 or 7, I think chapter 7. But at this moment, it's not that important, so I'm not going to spend too much time on it. X is in pth percentile, means p% is below X. So median is 50th percentile because it's right in the middle, 50% line. Q1 is 25th percentile, 25%. Q3 is 75th percentile, 75% line, and so on and so forth. For example, if you take an SAT exam, for instance, and then score 98 percentile, wow, that's great. That's because 98% of the students are below you, and only 2% of the students are above you. That's great. If you take SAT and score something like 13th percentile, and that's bad. Only 13 students are below you, and 87 students are above you, and that's bad. Okay, those are percentiles. I'm not going to go too deeply into that. 5-number summary is extremely important. Minimum, Q1, median, Q3, maximum. And the mean is, of course, important. Now, one more to go. Variance and standard deviation. This too is important, but I don't know if I'll have enough time to complete it in this video. If I don't, I'll just continue in the next segment. Here is the variance formula, and the standard deviation is the square root of that variance. Let me expand the font. Variance is basically the sum of xi minus x bar, which we call the deviation. Deviation is the distance between each datum and the mean. So how far away it is, how much deviated away from the mean. That's basically what this deviation is all about. And then this Greek letter sigma means sum them all up, add them all up. And please get used to it. We're going to use a lot of these. So whenever you see this, oh, there are a bunch of those add up like this. same thing, and there are hundreds of those, and add them all up. That's basically it. So distance between x1 and x bar, x1 is the first number and x bar is the mean. We have the deviation, and x2 minus x bar, again that's a deviation, how far away your datum is from the mean. But then again, if you add up all those deviations, then you're going to get nothing, because some will be above the mean, some will be below the mean, and positive and negative will cancel each other out. You're going to get nothing. So how do we measure the deviation? By squaring them and making everything positive, and then add up, then this numerator is positive. And divide by n minus 1, and that's a variance. Take the square root of that, and that's a standard deviation. Now, why n minus 1, not just n? Please don't ask me that question. We are not ready. In 3000 level applied math course, applied statistics course, excuse me, I tried to explain why we have n minus 1 instead of n, but even there, students weren't able to follow. So don't try to get this done. At this level, just accept it as a formula. For sample standard deviation, we have n minus 1 down there. We are not going to use population's standard deviation formula anywhere, except maybe 1 or 2 MyMathLab problem. Over there, it is n. So it can be a bit confusing. But overwhelming majority is sample standard deviation, so it's n minus 1 there. So this is really rare. Population standard deviation is really rare. Now, how do we calculate it? Well, let's see. Do we have an example problem here? Okay, here's one. We have this data set, same data set I believe, and we can calculate the variance and the sample standard deviation like that. But then again, how do we work out these formulas? It's kind of difficult to tell. So let me take much smaller data like this. And then let's take the mean. So mean of these 5 numbers. Okay, add them all up and divide by 5, and then you're going to get 66.4. So that's the mean. Now, how do we calculate the sample standard deviation? Here's a formula, and let's work it out. So first number is 69. 69 minus the mean. Square it. So that's this one. Do it again. 86 is next number, and subtract the mean. Square it. And then 77 minus 66.4 squared, 2 more to go. Okay, the numerator is complete, and divide by n minus 1, so 5 minus 1. If you calculate, this is gonna be the variance. This is variance. Now, how about the standard deviation? It's the square root of this quantity. And I'm using Mathematica, so it's easy to calculate. But if you have handheld calculator, this kind of computation can be pain in the rear end. Even with 5 numbers, it's going to be really rough. But up to 4 or 5 numbers, I've written those kind of problems, so please be prepared to calculate this kind of thing. If you have much larger data set, like about 20 numbers or 100 numbers and things like those, then you'll have to use technology. And that's something we're going to discuss in next section, section 3, Statistics and Technology.